You know, we all think of AI as this super fast electric brain, right? But what if I told you that for years, even our best and most powerful models have been kind of running with the brakes on? Seriously, a huge new breakthrough from NVIDIA is finally fixing that, teaching AI to be not just smart, but fast, like blindingly fast. So let's get into it and see how they pulled it off.
Okay, so what's the actual problem here? I mean, have you ever asked a chatbot a question and it just feels like it's taking forever? Yeah, that. The reason for that delay, it all comes down to how these models have been taught to talk. So the way it's usually done is something called autoregressive generation. Just imagine someone speaking really carefully. They say one word at a time. That's pretty much how most AIs work. They spit out a single word or a token, as it's called, then they stop, look back at everything they've said so far, think about it, and only then do they come up with the very next word. I mean, it's super precise, for sure, but it's also stuck in this slow, one-by-one process.
And here's where that becomes a huge problem. Our modern GPUs, they're absolute beasts at multitasking. They're built to do thousands, even millions of things all at the same time. But this one word at a time thing, it forces this powerful hardware to use just a tiny, tiny sliver of what it's capable of. It's literally like owning a Ferrari and only ever driving it in first gear. A complete waste of all that power.
And all that wasted potential, well, researchers have a name for it: free token slots. You can think of it like this. Imagine a giant conveyor belt, and for every one thing you put on it, there are 10 empty spaces right next to it, just flying by, completely unused. That's what's happening inside the GPU. All this power, all this space, just sitting there, empty, waiting for someone to figure out how to use it. All right, so obviously this slowness has been a major headache for a long time. Researchers have been trying to crack this nut from a couple of different directions. So let's look at the two big ideas that came out of that search for a faster AI.
So in one corner, you've got diffusion models. Think of these as the go fast option. They just blast out a whole sentence at once, which is super quick. The catch? They're kind of messy. They often sacrifice quality to get that speed. Then, in the other corner, you have something called speculative decoding. This one's a bit more clever. It uses a little draft model to quickly guess the next few words, and then the big, main model comes in behind it to check its homework. It's a neat idea, but it's complicated, and you're still juggling two different models.
So you see the dilemma, right? Neither of these was the perfect solution. You could either be fast and sloppy or careful and slow. You had to pick one. Well, that was the case until a team at NVIDIA came up with a brilliant new hybrid approach that, you guessed it, gives you the best of both. And it's called LiDAR.
Yup, this was all cooked up by a really sharp team of researchers right at NVIDIA. And their whole philosophy can be boiled down to this one really cool phrase: think in diffusion, talk in autoregression. I mean, how good is that? It just perfectly captures this idea of doing two different things at once.
And that right there, that's the genius of it, the big idea. Instead of forcing a choice between the fast, parallel thinking of those diffusion models and the super careful, high-quality talking of the old autoregressive way, they asked, what if a single model could do both at the exact same time? Okay, that sounds a little bit like magic, right? So how on earth does it actually pull this off? Let's get into the nitty-gritty of how LiDAR manages to do two totally different things in one single step.
It really does all happen at the same time. So in one part of its brain, the model is thinking. It's using those fast diffusion techniques to sketch out a bunch of possible next words all in parallel. But, and here's the cool part, at the exact same time, in the exact same computational step, it's also talking. It's using that super precise autoregressive method to double-check the words it drafted in the last cycle. So it's literally drafting the future while it's proofreading the present all at once.
The secret sauce here, the thing that makes all of this possible, is a really clever bit of engineering they call a structured attention mask. You can basically think of it as a traffic cop for the AI's brain, telling it exactly where to focus its attention and when, allowing it to look at different parts of the text at the same time.
So this mask carves up the whole job into three zones. First, you have the past. Here, it just uses that standard high-quality attention to look at the words it's already confirmed are correct. Then there's the present. It's using that same high-quality attention to verify the words it drafted just a moment ago. And finally, the future. This is where it flips the switch into that super fast parallel mode to dream up a whole new batch of draft words, past, present, and future, all handled in one smooth, elegant process.
Okay, so the theory is awesome, right? Super clever. But does it actually work?
what does this mean for performance in the real world? Let's check out the numbers, because this is where things get really, really wild. So for a pretty standard 1.5 billion parameter model, LiDAR gets a 4.71 times speedup. Let me say that again. That's almost 5 times faster. 5 times more words per second. And here's the kicker. It does it with zero loss in quality. None. You don't have to trade anything. You just get the speed. For free.
And it gets better. This thing scales like crazy. When they tested it on a bigger 8 billion parameter model, the speedup jumped to 5.91 times. That is almost 6 times faster. And yeah, there's a tiny bit of quality change, but it's so small it's basically unnoticeable. Just incredible. And that's really the big takeaway here. LiDAR is the first architecture to give you that insane parallel speed without sacrificing the gold standard quality we expect from the old school models. It just completely rewrites the rules of the game.
And this chart just lays it all out perfectly. You see that first bar? That's the old autoregressive method. Great quality, but slow. The middle one, speculative decoding, it gets you a little more speed, which is nice, but then look at LiDAR. It just completely blows past both of them. Way faster while keeping that quality right up there at the top. It's not just an improvement, it's a massive leap.
So let's zoom out for a second. What does this all mean for the future? Why is this one innovation such a huge deal for where AI is headed?
Okay, let's just quickly recap the big wins here. First, it's a single model. No clunky separate parts to worry about. Second, it finally lets our GPUs stretch their legs, using all that power we were wasting before. Third, it's super easy to use. No complicated knobs to tune. And the most important part, the quality is still top-notch.
Look, for so long in AI, the conversation has always been about trade-offs. You want it fast or you want it good. Pick one. LiDAR just comes along and says, why not both? It completely upends one of the most basic assumptions that has been holding back AI development for years.
And that really leaves us with one last huge question. For the very first time, our most powerful AI models can finally operate at a speed that actually matches their intelligence. So, now that they can think and talk this fast, what's next? What new problems are we about to solve? What frontiers that always seemed too far away are now suddenly right in front of us?